Good day and welcome to today's class. Today's class is a continuation of our previous class on trigonometry. At the previous class, we were able to look at the basic trigonometric ratios of sine theta, cos theta, and tangent theta with respect to a right-angled triangle. In today's class, we shall be looking at complementary angles. Two angles are said to be complementary if their sum gives you 90 degrees. We shall consider triangle ABC. In triangle ABC, at the last class, I told you that with respect to angle theta degrees, line AB, which is C, is said to be the opposite side to angle theta, while line AC is said to be the hypotenuse of this triangle ABC, and line BC is said to be the adjacent side. One of the basic theorems of a triangle is that the sum total of the angles in a right angle triangle is said to be 180 degrees. That is to say that if you add up angle A, which I said it is 90 minus theta, and angle B, which is 90 degrees, and angle C, which is theta, that their sum total gives you 180 degrees. And if angle B is 90 degrees and angle C is said to be theta degrees, then automatically angle A can be written as 90 minus theta degrees. So we said angle A plus angle C is said to be equal to 90 degrees. The sine theta, which we said at the previous class to be the ratio of the opposite side to the hypotenuse side, can be expressed to be C over B. Also, if you look at cos 90 minus theta, cos 90 minus theta, which is said to be the ratio of the adjacent side over the hypotenuse side, is equal to C over B with respect to angle 90 minus theta. So you will agree with me that sine theta is equal to cos 90 minus theta, which is equal to C over B. Also, sine 90 minus theta, if you look at the trig ratio, which is the ratio of the opposite side to the hypotenuse side, is equal to, when you consider triangle ABC with reference to angle 90 minus theta, A is said to be the opposite side, while B is said to be the hypotenuse side. Then the sine 90 minus theta degrees is said to be equal to A over B. And cos theta, which is the ratio of the adjacent side to the hypotenuse side, is equal to A over B. So therefore, we can also establish it that cos theta is equal to sine 90 minus theta. So we have established two facts. One is that cos theta is equal to sine 90 minus theta, while sine theta is equal to cos 90 minus theta. So whenever you have two complementary angles in a right angle triangle, the cos of one of the angle is equal to the sine of the other angle, while the sine of theta can also be said to be equal to the cos of 90 minus theta. Now this can help us in solving some trigonometrical problems. Let's take some examples. Example 1 says we should calculate theta if sine theta is equal to cos theta. Using the idea of complementary angles, you can be able to solve this. Now, that if sine theta is equal to cos theta, we should find the value of theta. We have established that sine theta can be expressed as cos 90 minus theta. I can then substitute cos 90 minus theta for sine theta, so that this can be said to be cos theta will be equal to cos into bracket 90 minus theta. By substituting this for this in this equation, you have cos theta to be equal to cos 90 minus theta. And if cos theta is equals to cos 90 minus theta, it therefore means that theta will be equal to 90 minus theta. The aim is for us to get the value of theta. So if theta is equals to 90 minus theta, we then have to collect like terms by adding theta to both sides. So this becomes 2 theta will be equal to 90 degrees. And when you divide both sides by 2, you have your value for theta to be equal to 45 degrees. So I was able to solve this using the idea of complementary angles. Let's take another example. Example 2 says, if sine theta is equal to cos 40 degrees, we should find the value of theta. Sine theta is equal to cos 40 degrees. We also know that sine theta is equal to cos into bracket 90 minus theta. So therefore, cos 90 minus theta is equal to cos 40 degrees. That is, when you substitute this for sine theta. So if cos 90 minus theta is equal to cos 40 degrees, it therefore means that 90 minus theta is equal to 40 degrees. And when you simplify to get the value of theta, you will agree with me that this becomes 90 degrees minus 40 degrees is equal to theta. So that 50 degrees is equal to theta, or we can say theta is equal to 50 degrees. So it is only sine 50 degrees that is equal to cos 40 degrees. You can verify this from your trigonometrical table that sine 50 degrees is equal to cos 40 degrees. Example 3 says we should solve the following. A says sine 3 theta is equal to cos 2 theta. We should find the value of theta. Solution. So if sine 3 theta is equal to cos 2 theta, and we have said that cos 2 theta is equal to sine into bracket 90 minus 2 theta, you substitute this for cos 2 theta in this equation. This becomes sine 3 theta to be equal to sine into bracket 90 minus 2 theta. I have eliminated cos from my equation, then bringing out the angles, that is 3 theta will be equal to 90 minus 2 theta. Simplifying this by collecting like terms, you have it to be 3 theta plus 2 theta to be equal to 90 degrees. And 3 theta plus 2 theta gives us 5 theta. So 5 theta is equal to 90 degrees. And when you divide both sides by 5, you have theta to be equal to 90 degrees divided by 5. 5 into itself is 1. 5 into 9 is 1, remainder 4. And 5 into 40 is 8, leaving us with 18 degrees. So theta is equal to 18 degrees. What this means is that if you multiply 18 by 3, the sine of it is equal to the cos of 2 times 18. B says cos theta plus 10 degrees is equal to sine theta. So if this is the equation, you can then start by saying sine theta is equal to cos into bracket 90 minus theta. Doing this, you are going to express this equation in terms of just sine theta or in terms of cos theta. So if sine theta is equal to cos 90 minus theta, I will then substitute cos 90 minus theta for sine theta in equation B, so that cos theta plus 10 degrees will be equal to cos 90 minus theta. So this invariably becomes theta plus 10 is equal to 90 degrees minus theta. Collecting like terms, you then have theta plus theta to be equal to 90 degrees minus 10 degrees, and 2 theta is equal to 80 degrees. Dividing both sides by 2, you get your answer that theta is equal to 40 degrees. So all this can be solved using the idea of complementary angles. Kindly like our videos as you watch, while we encourage you to subscribe to our channels if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can use the comment section to also interact with us on areas that are still strange to you. We also recommend you to share the links with your friends and family so that they can also benefit from this class. Let's take another example. Example 4. If a triangle has sides 8 cm and 5 cm and an angle of 90 degrees between them, we should calculate the smallest angle of the triangle. This is a WAEC question. By the question that we have a right angle triangle, let me call it triangle ABC, with angle A being 90 degrees, and that it has sides 8 centimeters and 5 centimeters. So let this be 8 centimeters, while this is 5 centimeters, and that we should calculate the smallest angle of the triangle. If this is theta, let this be 90 minus theta. Now we are to calculate the smallest angle. They didn't specify which of them is bigger and which is smaller, but from the given sides you can tell which angle is going to be bigger than the other, and the angle that is said to be bigger than the other is the angle with the biggest opposite side. So it therefore means that angle theta is bigger than angle 90 minus theta, reason being that the opposite side of theta is 8 degrees, while the opposite side to angle 90 minus theta is 5 degrees. So angle 90 minus theta is going to be the smallest side. So how do we get the value of angle 90 minus theta? We can therefore use our trig ratio by finding the ratio of the two sides. We have it that the ratio of the opposite to the adjacent side is equal to tan 90 minus theta. Let's call tan 90 minus theta to be alpha, so that we can say 5 over 8 is equal to tan alpha. So if 5 over 8 is equal to tan alpha, it therefore means that tan alpha is equal to 5 divided by 8 is said to be 0.625. Now what you will do in order to get alpha, go to your tan table and identify the angle that its tangent is said to be 0.625. That is said to be your angle alpha. So therefore alpha can be said to be the tan inverse of 0.625. You can directly punch this on your calculator to get your value of alpha, or you can use your trigonometrical table. So let's go to our trig table. Look out for 0.625. This is our tan table, tangent of angles. So you trace all the tangents to see which is 0.625. Now this is 0.0524, so we're looking for 0.625. So we trace it. 0.62, this is 0.62, 0.6224, 0.62, this is 0.6249. So our answer is approximately under 32. So this can be said to be 32 under 0 gives us 0.6249, which is approximately 0.625. So 0.625 under the tan table is said to be 32 under 0. So this can be said to be 32 degrees. So therefore, our alpha can be said to be 32 degrees. That brings us to the end of today's class. In today's class, we have been able to understand what we meant by complementary angles and also how the trig ratios of complementary angles are related. We have established the fact that sine theta degrees is equal to cos 90 minus theta degrees, as well as cos theta degree is said to be equal to sine 90 minus theta degrees, of which theta and 90 minus theta are said to complement one another because the sum of theta degrees and 90 minus theta degrees is said to be 90 degrees. Two angles are said to be complementary when their sum gives you 90 degrees. Thank you for being attentive in today's class. Kindly like our videos as you watch, while we recommend you to also subscribe to our channels if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. Kindly share the link with your friends and families so that they can also benefit from this project. You are also advised to use the comment section to interact with us on topics and issues where you are not cleared. Thank you for staying to the end of this class. See you in our next class. But before we go, let me leave you with an assignment that using the trigonometrical table, find the sine, cosine, and tangent of each of the following angles. You have angle 0.3 degrees, 60.5 degrees, 88 degrees, 45.2 degrees, angle 26 degrees, angle 108 degrees, angle 135 degrees, and angle 111.5 degrees. In the next class, I shall give you the solutions to all this before we move to the next topic. Thank you for being attentive. See you in our next class. Bye.